The threat includes Mount Rainier, which scientists continually monitor for activity. New at 6, come on, meteorologist George Waldenberger spoke with a geophysicist about what she's been observing.
A deep, bone-shaking rumble rolled through the Cascade Range before sunrise, rattling windows and pulling half-asleep residents to their doors. But this wasn't the sharp, jolting hit of a normal quake. This was a low, relentless vibration, like the ground itself was growling from miles beneath the surface. Mount Rainier, the massive ice-covered giant southeast of Seattle, had just stirred awake, and it wasn't a gentle stretch. Geologists didn't waste a second before dropping the rarest warning they've got, a red alert. The mountain people snap photos of for postcards had just reminded everyone, it's no harmless backdrop. It's a colossal beast capable of reshaping land and lives in hours. It all started a week earlier, so quiet most didn't notice. Instruments around Rainier picked up faint harmonic tremors, deep, low-frequency rumbles different from your usual earthquake. These aren't just random shakes. They hint at something moving through underground channels. On their own, they weren't panic-worthy. But then came the heat. Thermal sensors started flashing warning signs, sudden temperature spikes on the upper slopes and inside the summit crater. This wasn't a slow, creeping rise. It was like the mountain flipped a switch. Something big was shifting under all that snow and ice. Then GPS stations around the volcano caught it. The ground itself was swelling, just enough for the data to show it. That kind of bulge usually means magma's on the move or underground pressures climbing fast. The mountain was breathing, slow at first, then heavier, as its frozen crown began leaking wisps of steam visible for miles. With seismic activity kicking up, temperatures spiking, and the slopes literally puffing up, scientists had no choice but to double their monitoring. The final straw? A fresh burst of shallow earthquakes right beneath the summit. To experts, the pattern was crystal clear. It looked exactly like the prelude to an eruption. These quakes weren't big on the Richter scale, but they hit sharp, shallow, and fast, like the mountain's bones were snapping under pressure. Each jolt told the same story. Brittle rock giving way as something hot and heavy pushed its way up. The real oh no moment came when airborne thermal scans caught brand new fumaroles, vents ripping open along the summit's crater rim and blasting out scorching gases. Some of these spots had been stone cold for decades. Now they were glowing hot. The air readings didn't lie either. Sulfur dioxide and carbon dioxide levels were spiking hard. That's magma talking. Fresh, restless magma making contact with the surface environment. Within hours, the U.S. Geological Survey pulled the trigger. Rainier's alert level went straight to red. That's the highest it gets, meaning an eruption could be seconds away, or already in motion. Mount Rainier isn't just another volcano, it's a ticking monster. Its thick ice cap and its deadly closeness to millions of people make it one of the most dangerous peaks on Earth. Those massive glaciers? If the heat hits them hard, they could melt in hours, sending torrents of muddy volcanic water called lahars racing down the valleys at highway speeds. History's shown they can swallow entire towns, burying them under mountains of debris. As scientists combed through every fresh reading, the scale of what was happening hit them. This wasn't just another swarm of quakes. The tremors were paired with visible, physical changes. Satellite radar showed the summit bulging upward, centimeters in just days. For a mountain this massive, that's a lightning-fast shift. Something big was moving, and it was moving close to the surface. Temperature readings were off the charts. Snowfields that had been rock solid for decades were melting from below, carving hidden water channels through deep cracks. Steam plumes drifted downwind with a sharp sulfur bite, a reminder the mountain's insides were churning. Scientists warned that even without a full eruption, this heat could destabilize glaciers, unleashing ice collapses and avalanches that could mix with volcanic debris into deadly flows. The red alert wasn't guesswork. It was based on everything lining up at once. Intense quakes, swelling slopes, gas spikes, new vents, rapid heating, and visible summit activity. Rainier's structure makes it even more dangerous, built from layers of tough lava, but also weaker rock that crumbles when overheated. That means pressure could cause not just an eruption, but a massive slope collapse, triggering lahars racing toward nearby towns. And this isn't theory. It's happened before. Seismometers tracked quake patterns, gas sensors logged minute-by-minute changes, and drones braved the summit, streaming live images of steaming vents and bare rock where ice had suddenly vanished. Heat was pouring out from Rainier's crater, hot zones spreading like fire under ice. The mountain's frozen shell was reacting. Wildlife fled the upper slopes, streams ran cloudy with ground-up rock, and the air in certain valleys carried a faint metallic taste from volcanic gases drifting on the wind. Individually, these changes might slip under the radar. But together, they screamed that the mountain was shifting into a dangerous new phase. The human risk was massive. Thousands live in Rainier's shadow, with Tacoma and Seattle close enough to feel the impact. While an eruption could blast ash high into the sky, the most immediate threat was lahars, fast-moving walls of mud and debris funneled straight through populated valleys. History shows these flows have even reached Puget Sound. Geologists warned that Rainier's century of silence doesn't mean safety. It means magma and gas could be building up for something far more violent. And the signs now, rapid heating, new gas vents, and relentless quake swarms, fit the profile of a volcano going from quiet to alive. What shocked scientists most was how fast Rainier's mood flipped. Just days before the alert, the peak looked calm, glaciers glittering in the summer sun. Then, almost without warning, faint plumes began to drift from the summit. By the time they were obvious from nearby towns, the mountain's insides had already shifted dramatically. There was no time for slow escalation. Once the warning signs hit critical levels, the red alert was instant. Rainier's location makes this even more serious. It sits on a subduction zone where the Juan de Fuca plate dives beneath North America, fueling magma for the entire Cascade chain. Trouble at one volcano raises eyebrows for the others. Rainier's thick ice cover makes it tricky to read. Sometimes it hides changes, other times it makes them look worse than they are. That's why interpreting its signals takes years of experience, not just raw data. But with quakes, swelling slopes, gas spikes, heat surges, and new vents all lining up at once, there was no doubt this was a dangerous shift. Scientifically, the odds of an eruption had jumped. Humanly speaking, Rainier was sending a loud warning. The red alert wasn't a countdown. It meant the mountain had entered a phase where dangerous changes could hit without notice. From a distance, the summit still looked calm. But up close? The crater rim ice was sagging, heat warping its edges. Mineral-rich steam stained the snow yellow and rust. Small avalanches tumbled more often, hinting that vibrations were shaking loose rock and ice. All signs pointed to magma rising, breaking rock and releasing gas. The spike in sulfur dioxide meant degassing was already underway, with molten rock possibly just kilometers from the surface. Rainier's vast glaciers, beautiful but dangerous, were now potential fuel for a lahar disaster. For scientists who had spent careers studying this giant, it was a sobering sight. The serene mountain had turned into an active threat, and every new reading carried the weight of possible catastrophe. This was the deceptive calm before whatever came next. The volcano's heartbeat was quickening, its rhythm more erratic by the hour. Heat shimmered above the summit, a silent sign of the power building inside. Rainier was no longer a backdrop. It was now an active player in the region's story. The red alert wasn't just science. It was a call for vigilance, preparation, and respect for the force hiding under those snowy slopes. After the alert, the mountain dominated the horizon like never before, its beauty laced with danger. From the air, scientists spotted thin but steady vapor columns rising from multiple points along the summit ridge. Instruments confirmed they carried acidic volcanic gases, proof the heat wasn't coming from one vent, but from several fractures feeding pressure release. The chemistry was shifting too. At first, the plumes held more carbon dioxide than sulfur dioxide, a sign of magma still deep below. But within hours, sulfur dioxide spiked, classic evidence that molten rock was now moving closer to the surface. Magma was now nearing zones where it could hit groundwater or glacial melt, conditions ripe for sudden steam blast explosions with zero warning. Seismic monitors picked up a new signal, volcanic tremor, a constant, low-frequency hum lasting for hours, even days. This wasn't preparation anymore. The system was in motion. The tremor began shifting downslope, hinting that molten rock and gas were carving new pathways inside the volcano. Surface signs backed it up. Climbers reported fresh sinkholes near the summit, their rims steaming, exposing dark, thawed rock. Just days earlier, those spots had been solid ice. These weren't harmless features. They could collapse in seconds, swallowing anything nearby. Satellite images showed the summit rim beginning to sag on the eastern side while other areas were swelling, proof that internal pressure was building unevenly, stressing the mountain from within. The imbalance inside Rainier was dangerous. Its weakened flanks made it vulnerable. Deep below, magma was forcing through fractures, heating groundwater, and rewiring the volcano's plumbing. Stable hydrothermal systems were breaking down, raising the risk of sudden gas bursts, steam geysers, or even eruptions far from the summit. Glaciologists watching the Emmons and Nisqually glaciers saw cracks widening fast and new fractures forming, mirroring underground deformation. Some meltwater was pooling inside the ice, hidden reservoirs that could unleash deadly lahars even without an eruption. Up high, rangers felt a steady, low rumble underfoot, like distant machinery. Down below, you couldn't hear it, but you could see it. On clear mornings, Rainier's steam plumes rose in constant streams, catching sunlight and stretching across the sky. This wasn't the occasional wisp of past years. It was continuous venting, laced with hydrochloric acid and fine mineral dust, proof that the volcano was bleeding heat and pressure into the open air. By now the signs were undeniable. Rainier was in a critical state. Instruments showed pressure inside the volcano climbing at a pace not seen in decades. Gas emissions were holding at dangerously high levels, with sulfur dioxide readings peaking and staying there. The constant volcanic tremor had deepened in tone, a low, resonant hum that geologists knew meant one thing: magma was still rising. Thermal imaging revealed entire sectors of the summit rim glowing hotter than before, heat bleeding through the ice in sprawling patterns. From the air, fractures could be seen zigzagging across the upper slopes like scars, some stretching hundreds of meters. Emergency planners were on standby, aware that the smallest trigger, a rockfall, a sudden pressure shift, or the collapse of a glacier wall, could set off a chain reaction. Whether it began with an explosive blast, a flank collapse, or a torrent of lahar roaring down the valleys, one fact was clear: the mountain wasn't backing down. Every plume, every quake, every vibration was part of a countdown no one could read. The acid in Rainier's steam came from volcanic gases colliding with water vapor, while the fine mineral dust revealed rock being shattered and carried into the air. Each grain was like forensic evidence, proof of the grinding chemical warfare happening deep inside the mountain. In Rainier's long history, some of its most violent moments have come when magma meets its massive ice cap. The outcome has always hinged on three factors: internal pressure, surface stability, and how much ice there is to melt. But this time, the glaciers are more fractured than in decades, their climate-thinned layers riddled with new pathways. That means meltwater could find magma faster than ever before, setting the stage for an explosive chain reaction. Rainier's next move could come without warning, and when it does, it won't just change the mountain, it could change everything around it. If you found this breakdown gripping, hit subscribe, like, share, and drop your thoughts in the comments. Let's keep the conversation alive, because this story is far from over.